what do you think the most crucial organism on Earth is? 1 year ago, I would have thought that these are bees, because bees fly around, pollinate flowers, create food for animals and for humans. But it turns out that bees only have a good PR and marketing strategy. In fact, they are not that crucial. Others would argue that other humans are the most crucial organisms on Earth because we kind of need each other to recreate and create babies. But I invite you to think of something more immediate, more imminent, more crucial than food or recreation. And that is, take a deep breath. Yes, that is breathing, that is breathable air, that is oxygen. So 1 year ago, I would have thought that trees are the most crucial organism on Earth because we are told all the time to plant more trees. But it turns out that trees, just like bees, only have a good marketing and PR strategy. In reality, trees produce only 20 to 30% of the Earth's oxygen. So where does the rest of the oxygen comes from? That thing lives in this water. Can you see it? No, you cannot, because this organism is so tiny, so microscopic, that it cannot be seen from the naked eye. It represents only 1% of the Earth's biomass, but it produces over 50% of the Earth's oxygen. Yet, 200 years ago, we didn't even know it existed. And this thing is phytoplankton. Phytoplankton is a tiny plant that lives in water bodies everywhere on Earth. It lives in the icy water around Antarctica, it lives in the Niagara Falls, and it lives in water droplets coming down with rain. It produces over 50% of the Earth's oxygen, but not only that, it supports 4 other United Nations Sustainable Development Goals. Too much phytoplankton can be toxic, therefore it directly impacts good health and well-being and clean water and sanitation. Some type of phytoplankton, if it comes in contact with humans, it can be so toxic that it can kill humans. Phytoplankton also forms the basis of the aquatic food web. This means that in one way or another, every single animal in the ocean feeds on phytoplankton. Therefore, it is important for life below water. Finally, phytoplankton not only produces over 50% of the Earth's oxygen, but also it captures carbon from the atmosphere and sinks it to the bottom of the ocean for thousands of years. So how did we learn 150 years ago that phytoplankton even exists? There is one crucial quality of phytoplankton that makes it visible. And that quality is that phytoplankton is a little bit cannibalistic. They like to eat their neighbors. And so when they come together in high concentration, they change the color of the water. This is a greener type of phytoplankton, and it is a redder type of phytoplankton, if you can see it. They change the color of the water not only in laboratory settings, but in a large scale, they change the color of oceans. 150 years ago, this device was developed. This is called the Forel scale, and this is an early device to try to categorize the color of the water and therefore understand how phytoplankton is changing the color of the water over time. This device was developed by a Swiss scientist called Francis Alphonse Forel, who was right here at Lake Geneva. 50 years passed since, and we sent the first human into outer space. This is Yuri Gagarin, about 60 years ago, the first human in space. When the first astronauts were in space, they looked back on our globe and saw that the globe is blue, but not always blue, especially when they were looking at the oceans. For instance, this is here, northern Italy, southern France, and they saw these formations on the water, these kind of green formations on the water. And it turns out that all this is phytoplankton. This makes phytoplankton not only one of the most crucial organisms on Earth, but also one of the only ones that is visible from space. Some of these phytoplankton formations can be so big that they are bigger than the entire European Union. Therefore, the only place where we can monitor them meaningfully is from space, because that is the only place from where we can see the entire formation. Phytoplankton is also naturally present at Lake Geneva. Here is one of the blooms of phytoplankton a couple of years ago, and on the visualization, you can see how the water currents of Lake Geneva are pushing around the phytoplankton in the water. So phytoplankton is so important that only 4 months ago, NASA gave phytoplankton its own satellite. This satellite is called the PACE satellite, where P specifically stands for phytoplankton. So phytoplankton put this satellite into orbit, and this satellite put me on this stage. I am a Harvard data science student, and in the past 1 year, I have been working with my colleagues, developing AI models to use this satellite's data and better understand how the various colors of phytoplankton are changing the color of the oceans globally. Here you can see the 4 typical phytoplankton colors that I also displayed earlier, and kind of an AI-based visualization of which phytoplankton thrives where. Why is it important? Because some of the phytoplanktons are better at some things than in others. One is better at producing oxygen, the other one is better at feeding other animals, and there is one, this one right here, that is so toxic that it can kill humans. So don't drink this one. Now I know what you are all thinking. Phytoplankton is so cool, you wish you could be more like phytoplankton. And there is a good news. Phytoplankton is actually a superfood, not only for aquatic animals, but for humans as well. So in case you wanted to taste phytoplankton, I welcome you to come to booth 61, the Harvard for NASA booth, and taste this fantastic animal. Thank you very much.